6, 5, 4, 3, 2, 1. MDS, we have ignition, we have a liftoff.
NASA launched the Voyager 1 and Voyager 2 spacecraft in 1977 with the intention of exploring the far limits of our solar system and beyond. The Voyager missions have returned a plethora of information throughout the years, giving us previously unheard of insights into outer planets and their moons, and even traveling as far as the edge of our solar system. However, scientists are baffled by a recent finding made by Voyager 2 of an unidentified force in outer space. What are the specifics of this enigmatic force discovered by Voyager 2? What does this finding signify for us exactly? Let's find out. It's crucial to first comprehend what Voyager 2 is and what its purpose has been before delving into the mysterious power that it has uncovered. NASA launched the sibling spacecraft Voyager 1 and Voyager 2 around the same time in 1977. Exploring the outer planets of our solar system, such as Jupiter, Saturn, Uranus and Neptune, was Voyager 2's main objective. Voyager 2 became the second artificial object after Voyager 1 to continue its voyage into interstellar space after completing its initial mission. Only 5 human-made spacecraft have ever been launched that have had enough energy to escape the gravitational pull of our solar system. The Sun is more than 300,000 times as large as our home planet and far harder to escape from, even though thousands upon thousands of items have been sent into space, defying the gravitational pull of planet Earth. Only Pioneer 10 and 11, Voyager 1 and 2, and New Horizons were able to reach escape velocity from our Sun, which required both rapid launch speeds and gravitational assistance from other planets. Pioneers 10 and 11 are no longer in operation, but the radioisotope thermoelectric generators that power New Horizons and both Voyager spacecraft enable them to continue operating. Ahead of the slightly slower Voyager 2, which is only 18.8 billion kilometers away, Voyager 1 has passed all other spacecraft and is now the most distant at a distance of 22 billion kilometers. NASA was not able to speak with Voyager 2 throughout the coronavirus pandemic, but an upgraded Deep Space Network dish made a successful call on October the 29th of that year. You should understand that 3 obstacles must be overcome in order to send and receive messages at cosmic distances. They are distance, time, and power. The further a spacecraft is from you, the longer it takes for a signal you send to get there. The lesser its power, when it does, the longer it has to go. Since light signals spread out in the 2 dimensions perpendicular to the spacecraft's line of sight, if a spacecraft is twice as far away as another, the distance to it is twice as great, and the time it takes a light signal to travel to it is twice as great, and the signal power that it receives is only 1/4 as great. The farther distance a spacecraft is, the harder it is to communicate with it, and the longer it takes to communicate with it, the more energy is needed to send or receive the same signal. Whether you're using a refracting lens, a reflecting dish, or a linear antenna to detect the electromagnetic signal, it always spreads out in a spherical pattern from its source. You need your signal to reach a specific threshold in order to be observable, rising above the noisy background, because there is a certain level of inherent background noise to any observation you would make, from both terrestrial and celestial sources. It implies bigger detectors are better on the receiving end, while a more powerful transmitter is better on the transmitting end. Sadly, the hardware of the spacecraft that have already been launched cannot be modified in any way. Once they have been launched, they are confined to using the technology they have been given. The fact that the spacecraft are themselves powered by radioactive sources, where carefully selected material, such as plutonium-238, radioactively decays and emits heat that is then converted to electricity, makes matters worse. More and more of the substance decays over time, reducing the power available to the spacecraft for signal transmission and reception. The conversion of heat energy into electrical energy is less successful, as radioactive material produces less heat energy because the thermocouples deteriorate over time, and lose effectiveness at lower powers. The power supplied to the spacecraft by the radioisotope thermoelectric generators has consequently sharply dropped. By 2020, the onboard plutonium-238 will only generate 69% of the initial thermal energy, which will equate to only around 50% of the initial output power. Despite being 46 years old and further away from Earth than any other functioning spacecraft in history, Voyager 1 and 2 are still accessible to us. The explanation is straightforward. As our transmission and reception skills on Earth advance, we can both send out stronger signals for these far-off spacecraft to receive and perform a better job of identifying their responses, even at low levels. NASA's Deep Space Network, a system of radio antennae built to connect with humanity's farthest spacecraft, holds the key. There are 3 significant radio antenna facilities in the world, one each in Goldston, California, Canberra, Australia, and Madrid, Spain. You might be aware that the only facility on Earth is situated in the southern hemisphere, and that facility is Canberra, Australia. The Australian dish would be the only one to contact a spacecraft that is very far south, so far south that it is invisible from places like California or Spain. While all 3 of these sites might theoretically make contact with Pioneers, New Horizons, and the Voyager 1 spacecraft, Voyager 2 is the outlier due to its 1989 flyby of Neptune and its enormous moon Triton. The journey to Neptune still stands as humanity's first close encounter with Triton, the largest known object to have originated in our Kuiper belt, as well as with our solar system's 8th and last planet for now. The findings from that flyby were amazing. A number of fantastic features, including Neptune's rings, a number of small inner moons, and a number of features on Triton, including cryovolcanoes and varied terrain, were found. These features were similar to those we would find on Pluto some 26 years later, when New Horizons flew past the planet. Voyager 2's trajectory was deflected far south of the plane in which the planets orbit the Sun, forcing Voyager 2 to fly across Neptune's North Pole in order to have a near encounter with Triton. With the exception of one dish in Australia, it has followed that course for the past 34 years, making it invisible to every member of the Deep Space Network. And that dish, which houses the radio transmitter used to communicate with Voyager 2, was shut down in the middle of March 2020 for upgrades. The dish itself is an amazing piece of engineering, a top-notch radio antenna measuring 70 meters, that's 230 feet in diameter. 2 radio transmitters are affixed to it, one of which is used to communicate with Voyager 2. By the beginning of 2020, that instrument was now 47 years old and had never been updated. It also made use of outdated electronics, outdated heating and cooling systems, and a set of power supply components that prevented future updates. Thankfully, it was decided to improve all of these, allowing NASA to accomplish something that no other agency can: send directives to Voyager 2. The spacecraft has been unable to receive commands, meaning that it will continue to do whatever it was doing until those new commands are received. The spacecraft is still operating, however, and is sending science data and health updates that can be received by a number of smaller dishes that are also located in Australia. On October 29, 2020, the improvements had been carried out to the point where mission controllers for Voyager 2 made the crucial decision to conduct a test, to send Voyager 2 a sequence of directives for the first time since the upgrade started. Although it takes a signal from Earth to Voyager 2 for a round trip of around 36 light hours, NASA declared that the test was successful. After successfully executing the directives, Voyager 2 signaled that the call had been received. What is the mysterious force that Voyager 2 has discovered? A mysterious force in outer space was discovered by Voyager 2 in 2019, more than 40 years after its launch. Voyager 2 was the first spacecraft to notice this force, which has been termed the interstellar surprise when it crossed the border between our solar system and interstellar space. The solar wind, a stream of charged particles coming from the Sun, collides with the interstellar medium, the gas and dust that fills the space between stars, at a limit known as heliopause. Voyager 2's plasma science experiment, PLS, which analyzes the density, temperature and velocity of the particles in the plasma or ionized gas that surrounds the ship, discovered the interstellar surprise. The PLS noticed an abrupt rise in plasma density that persisted for nearly 2 days. This increase was accompanied by a drop in plasma temperature and a shift in the magnetic field's polarity. Scientists had anticipated that the plasma in interstellar space would be considerably less dense and cooler than the plasma in our solar system. Thus, these alterations came as a surprise. What might be the origin of the mysterious force? Scientists are baffled by the discovery of the interstellar surprise because it is not yet known what could be driving the abrupt jump in plasma density and the modification of the magnetic field. To explain this enigmatic power, however, a number of theories have been put forth. One idea holds that a magnetic reconnection event caused the interstellar surprise. As the magnetic field lines in a plasma collide and combine, a burst of energy is released and magnetic reconnection takes place. The abrupt rise in plasma density and modification of the magnetic field that Voyager 2 measured may be due to this energy explosion. Another hypothesis holds that a supernova explosion's shockwave caused the interstellar surprise. A shockwave is produced when a star explodes in a supernova and travels across the interstellar medium, compressing the gas and dust and raising its temperature. This may be the cause of Voyager 2's observed abrupt drop in temperature and rise in plasma density. The interstellar surprise could also be a normal change in the interstellar medium, which is still poorly understood. Scientists now have a rare opportunity to examine the interstellar medium in depth and learn more about the intricate interactions between the solar wind and the interstellar medium, thanks to the data from Voyager 2. What does science gain from this discovery? Voyager 2's finding of the interstellar surprise has significant ramifications on how we comprehend the far limits of our solar system and beyond. Voyager 2's discovery of this enigmatic force has given researchers a wealth of fresh information and insights about the composition of the interstellar medium. The fact that this discovery raises the possibility that the interstellar medium is more complicated and dynamic than previously believed is one of its most important consequences. Voyager 2's discovery of a sudden rise in plasma density and a shift in the magnetic field may indicate the existence of as yet unidentified physical processes operating in the interstellar medium. These processes could have significant ramifications for our understanding of the universe as a whole. The finding of the interstellar surprise also emphasizes the value of continuing to explore and research the solar system and beyond. The ongoing value of scientific inquiry and discovery is illustrated by the Voyager missions, which were started nearly 46 years ago and are still producing fresh insights and discoveries.